The result is provided by an AI engine, amortization, prediction program for 10 different machines. Let's break down how to understand it. Please subscribe to the channel and motivate the author to produce more white paper and videos related to AI engine for business. At the end of the video, about AI engine designing concept. Book for your library. Scan QR code, bookstore in the cloud sun behind large cloud. Pradeep K. Suri. Author, researcher, and AIDNN architect. Machine details. Machine ID, a unique identifier for each machine. Name, the name of the machine. Cost, the initial cost of the machine, in Indian rupee. Lifespan, the expected number of years the machine will be operational. Annual amortization, the predicted annual expense you can account for as the machine's value gets used up over its lifespan. Understanding annual amortization. This value, annual amortization, represents the portion of the machine's cost that is considered used up each year. It helps spread the initial cost over the machine's lifespan, providing a more accurate picture of your company's financial health. Observations in the results. Cost variation, the machines have varying costs, ranging from 816,967 Indian rupees, machine ID, 1, to 1,197,623 Indian rupees, machine ID, 10. Lifespan consistency, all machines have a predicted lifespan of 30 years. Amortization correlation, the annual amortization cost generally correlates with the initial machine cost. Higher cost machines typically have higher annual amortization. However, there are exceptions, example machine ID, 3 versus machine ID, 5, this could be due to the program's prediction considering additional factors beyond just cost. How this information is useful. This information can be used for various purposes in your business. Budgeting, you can use the annual amortization figures to plan for the ongoing cost of using these machines in future years. Financial statements, amortization expense is reflected in the income statement, impacting net income. This helps maintain accurate financial reporting. Decision making, when evaluating new machines, you can compare their predicted amortization costs with expected benefits to make informed investment decisions. Overall, this amortization prediction provides valuable insights into the annual financial impact of these machines on your company. The program is a machine learning, ML, program. Here's why. Learning from data, the program utilizes a training phase, train_model function, where it analyzes a sample dataset, potentially containing cost and lifespan of various machines with their corresponding annual amortization values. This training allows the program to learn the underlying relationship between these features, cost and lifespan, and the target variable, annual amortization. Prediction, after training, the program can take new, unseen machine details, cost and lifespan, and predict the annual amortization cost using the learned relationship, predict_amortization function. Linear regression model, the program employs a specific ML algorithm called linear regression. This algorithm identifies a linear relationship between the features, cost and lifespan, and the target variable, annual amortization, based on the training data. Libraries for ML tasks, the program leverages libraries like scikit-learn which provide tools commonly used in machine learning, such as linear regression model building and data pre-processing. In essence, this program exemplifies how machine learning can be applied to financial tasks like amortization prediction. It learns from historical data and uses that knowledge to estimate amortization for new machines. Here are a few ways to integrate the provided ML program into AI engine. 1. Exposing the program as a service, API. Create a web service using a framework like Flask or Django. Wrap the predict_amortization function inside the web service to expose it as an API endpoint. The AI engine can then interact with this API endpoint to make amortization predictions for new machines. This allows the AI engine to leverage the ML model without directly incorporating the entire program. 2. Converting the program to a library. Refactor the program into a well-structured Python library. The library should provide functions for loading the model, pre-processing data, and making predictions. The AI engine can then import this library and utilize its functions for amortization tasks. 3. Integrating the program directly, if suitable. If your AI engine is built using Python and utilizes similar libraries, like scikit-learn and Pickle, you might consider directly integrating the program. This would involve copying the code into your AI engine's codebase and ensuring proper dependencies are met. This approach offers tighter integration but requires maintaining the amortization code within your AI engine. Here are some additional points to consider. Data integration. How will the AI engine provide the cost and lifespan data for prediction? You might need to modify the program to accept data from the AI engine's internal format. Model updates. Consider how you'll handle model updates in the future. The program currently trains a new model each time it runs. You might want to create a separate training script and update the saved model periodically. Deployment. Depending on your chosen integration method, you'll need to consider deployment aspects. For example, if using an API, you'll need to deploy the web service hosting the API. The best approach depends on the specific architecture of your AI engine and its development environment. Choose the method that offers the most flexibility and maintainability. The program is designed to predict the annual amortization cost of a machine based on its initial cost and lifespan. Here's a breakdown of the functionalities. Importing libraries. NumPy, NP used for numerical computations with arrays. sklearn.linear_model, provides the linear regression class for building the prediction model. Pickle, used to save and load the trained model and scalar. sklearn.preprocessing, provides the standard scalar class for data preprocessing. Functions. Preprocess_data, x. This function takes input data, x, and performs standardization using standard scalar. Standardization helps improve the performance of the linear regression model. Train_model, x, y. This function trains a linear regression model using the provided input data, x, and target values, y. In this case, x is a 2D array with each row representing the cost and lifespan of a machine, and y is a 1D array containing the corresponding annual amortization values, cost divided by lifespan. Save_model, model, scalar. This function saves the trained model, model, and scalar, scalar, using Pickle for future use. Load_model, this function loads the previously saved model and scalar using Pickle. Predict_amortization, model, scalar, cost, lifespan. This function takes a machine's cost and lifespan as input, pre-processes the data using the loaded scalar, and then uses the loaded model to predict the annual amortization cost. Input_machine_details, this function prompts the user to enter details like machine ID, name, cost, and lifespan. Print_machine_details, ID, name, cost, lifespan, annual_amortization. This function takes machine details and the predicted amortization cost and prints them in a formatted way. Main, this is the main program that runs when you execute the script. It prompts the user for machine details, trains the model if it's the first run, predicts amortization, and finally prints all the information. Overall, this program demonstrates how to build and use a simple machine learning model for amortization prediction. It takes advantage of scikit-learn libraries for linear regression and data preprocessing, and Pickle for model persistence. The program is a machine learning, ML, program. Here's why. Learning from data, the program utilizes a training phase, train_model function, where it analyzes a sample dataset, potentially containing cost and lifespan of various machines with their corresponding annual amortization values. This training allows the program to learn the underlying relationship between these features, cost and lifespan, and the target variable, annual amortization. Prediction. After training, the program can take new, unseen machine details, cost and lifespan, and predict the annual amortization cost using the learned relationship, predict_amortization function. Linear regression model, the program employs a specific ML algorithm called linear regression. This algorithm identifies a linear relationship between the features, cost and lifespan, and the target variable, annual amortization, based on the training data. Libraries for ML tasks, the program leverages libraries like scikit-learn which provide tools commonly used in machine learning, such as linear regression model building and data pre-processing. In essence, this program exemplifies how machine learning can be applied to financial tasks like amortization prediction. It learns from historical data and uses that knowledge to estimate amortization for new machines. Thank you.